first one, we form the augmented matrix whose first column is A and last column is B, symbolically like this, just like the elimination or elementary row operations you have learned before. Because actually the Gauss-Jordan elimination method is the application of all the elementary row operations to reduce the augmented matrix to obtain the reduced augmented matrix RAM. Here is the bigger picture of the process. So from here, as you apply all the elementary row operations steps, the final one, you will get the A as an identity matrix, and the X here is the solution matrix representing all the solution of X, Y, and Z. First of all, you form an augmented matrix form, which is like this. The matrix is 1, -3, 1, 1, 1, 1, and 2, -1, 1. -12, 0, 8. Here is the A and here is the B. Now we apply the elementary row operations. Step 1, you want to obtain the leading diagonal here as 1. Since it is already 1, so we can skip step 1. Now we move to step 2. Step 2, here, you want to obtain the element under the leading diagonal at the first column to 0. So since at the row 2 is 1, 1 minus 1 is 0. Here is the formula for step 2. So what will you get? 1, -3, 1, -12. And then 0, 4, 0, 12. 0, 5, -1, 16. For step 3, you want to obtain the element in leading diagonal at second column to 1. So since it is the leading diagonal element, so the new row 2 is equal to the original row 2 divided with 4. Then you will get everything here: 1, -3, 1, -12. 0, 5, -1, 16, 0, 1, 0, and here is 3. Understand? Then we move to step 4. Step 4 is the element above and below the elements of leading diagonal, which so the new row 1, since you want to obtain into 0, so the new row 1 will be the original row 1 plus 3 row 2. and the new row 3 will be the original row 3 minus 5 row 2. Understand? So what will happen, we copy back the one that we didn't change first, and then it will be 1 0 1 negative 3, 0 0 negative 1 and 1. Then for step 5, you want to change the leading diagonal into 1. So the row 3 is equal to negative row 3. So what will happen is 1 0 1 negative 3, and then 0 1 0 3 and 0 0 1 negative 1. Then lastly, for the last step, you want to obtain the row above the leading diagonals element into 0. So since the row 2 is already 0, so you just work on row 1. So row 1, it will be equal to the original row 1, you minus it with row 3. So you will get 1 0 0 0 1 0 0 0 1 negative 2 3 and negative 1. So now you have obtained here in form of identity and here in the form of x. Then you have the final solution. The value of x will be negative 2, the value of y will be 3, and the value of z will be negative 1. Understand? We proceed to the last example, which is example 5. Okay, so now Ali, Bob and Ravi bought tickets for 3 separate performances. The table below shows the number of tickets bought by each of them. Here, as you can see, it is already in a matrix form. So the first question, if the total cost for Ali was Rm 122, for Bob Rm 87, and for Ravi Rm 146, represent this information in the form of 3 equations. So the solution will be 2x plus y plus z equal to 122. The second equation will be x plus y plus z equal to 87. And lastly, the last equation, 2x plus 2y plus 2z is equal to 146. For the question B, find the cost per ticket for each of the performances. Meaning here, the cost per ticket, you want to know what is the value of x, y, and z. So how to solve the systems of linear equations from A by applying the Gauss-Jordan method. So the first step, you form the here 2 1 1 1 1 1 and 2 2 1. Here will be 1, 2, 2, 87 and 146. Okay, now we're going to work on the Gauss-Jordan steps. So firstly, the leading diagonal here, you want to obtain it into 1. So the first step, since the row 2 is 1 already, so we just applying the interchanging row. Carefully, to prevent carelessness, you will get 1, 1, 1, 87. 2, 1, 1, 122. 2, 2, 1, 146. Understand? Then, for step 2, you want to obtain the element under the leading diagonal into 0. So what will happen? The new row 2 is equal to the original row 2 minus it with 2 row 1. And then the new row 3 is equal to the original row 3 minus 2 row 1. So 1, 1, 1, 87. For row 2, the new row 2, by applying all the elements in the row 2 into this formula, you will get 0, negative 1, negative 1, negative 52. And then for row 3, 0, 0, negative 1, negative 28. Understand? Then we move to step 3. Step 3 is where you want to obtain the leading diagonal here into 1. So the new row 2 is equal to negative row 2. Then the solution you will get is 1, 1, 1, 87. 0, 0, negative 1, negative 28. Here 0, 1, 1 and 52. Okay. Then next you will have step 4 to obtain the element here and here into 0. Since the row 3 is already 0, so you just work on row 1. So what will happen is the new row 1 is equal to row 1, and then you minus it with row 2. Right? So the solution will be 0, 1, 1, 52, 0, 0, negative 1, negative 28. And then you will have here 1, 0, 0 and 35. We work on step 5 to obtain the element in the leading diagonal into 1. So row 3 is negative row 3. Then the solution will be 1, 0, 0, 35 and 0, 1, 1, 52 00128. The final step, which is step 6, is where you want to obtain the the element above the leading diagonal into 0. Since the row 1 is already 0, you just work on the row 2. So last step, the new row 2 is equal to the original row 2. You minus it with row 3. So you will get 10035 and 00128. So it will be 1010 and 24. Okay, then you have already obtained the matrix here as an identity matrix, and it is matrix X. Okay, so you need to do a conclusion here. X is 35, Y is 24, and Z is 28. The conclusion here is the cost for concert is Rm35 per ticket. Cost for orchestra is Rm24 per ticket. And lastly, cost for opera is Rm28 per ticket. That is the application of Gauss-Jordan method and matrices in the real life problems. Understand? And then for last question, the question asks you, determine how much it would cost Hassan to purchase 2 concerts, 1 orchestral and 3 opera tickets. This is just the basic mathematics knowledge. So the amount Hassan has to pay for tickets is 2x plus y and 3z plus. So what is the value of x? Here 35 plus 24 and plus 3 times 28. Since you are doing all in the ringgit Malaysia, so the final answer is 178.00. Understand, everyone?